All right, so again, we are just going to keep simplifying. So in our next example, problem 17, we're going to need to switch forms. And again, that negative is going to have to stay on the outside because we don't have parentheses. So this really means the negative fourth root of 16. And 16 is a perfect fourth. So I'm going to put my 3 on the outside. So the fourth root of 16 is 2. So we're going to have 2 cubed, negative is still on the outside. So 2 cubed is 8, and then we would multiply it by that negative. So our final answer for this one will be negative 8. All right, next one. So again, I'm just going to switch forms. So cubed root of negative 27, x to the negative 9th. So cubed root of negative 27 will be negative 3. And then negative 9 divided by 3 will be x to the negative 3rd. So again, because I have that negative exponent, we need to move just the x term down to the denominator. So our final answer for this will be negative 3x cubed. All right, 19. So again, I'm going to want to switch forms for this one. So we're doing a cubed root. So this really means the cubed root of 27x to the 6th over the cubed root of 64, and then we have y to the 4th. So I'm going to split this right away. So I'm going to use y cubed and y. And then again, we're just going to simplify. Cubed root of 27 is 3. 6 divided by 3 is 2, so we'll have an x squared. Cubed root of 64 is 4. 3 divided by 3 is 1. And then that y is going to have to stay on the inside, so cubed root of y. And because we have a radical in the denominator still, we will need to rationalize. So we're trying to create a perfect cube. So we're going to multiply by the cubed root of y squared, the top and bottom. So in the numerator, we now have 3x squared, cubed root of y squared, over 4y, and then the cubed root of y cubed, which we can keep simplifying. So the numerator we can't, so that will stay the same. So 3x squared cubed root of y squared. And then when I simplify, 3 divided by 3 is 1, so this will become a y. And then we have to multiply it to the y that's already there. So it'll be 4y squared for our final answer. Right, next problem. So 20, we're just multiplying. So we're going to multiply the 2 and 6 to get 12. And then because we're multiplying with the same base, we're just going to add the exponents. So that means that we're taking 2/5 plus 1/4. So to do that, again, we need a common denominator of 20. So for this one, we would have multiplied by 4, so this will be 8, multiplied by 5. 8 plus 5 is going to give us 13 over 20. So x to the 13/20ths. And we can't simplify that, because even if we switch forms, this would be 12 times the 20th root of x to the 13th power. So that can't be reduced. So either one of these answers would be acceptable. All right, and the next one. So let's see, so we have a negative exponent. So again, we're going to make our fraction, move it down to the denominator. And then at the same time, I'm going to switch forms to make it a little bit easier. So this will become 1 over the 5th root of y to the 4th, which we can't simplify, so we do need to rationalize. So we're going to multiply this by the 5th root of y, so y to the 1st, so that'll create my perfect 5th. Same thing to the numerator. So now we will have the 5th root of y over the 5th root of y to the 5th, which we can then simplify. So we have the 5th root of y over y. So we took 5 divided by 5 to get 1. All right, and we'll finish up the last 3 examples in the next video.